Hey guys, my name is Andrew, founder and CEO at Extractor Depot, and I'm excited to bring you Tech Tip Tuesday number 36. This one will be a continuation of the last Tech Tip Tuesday. So let's assume that we've identified some of our bottlenecks, the first being recovery speed. In the last episode, I mentioned the importance of heating capacity and cooling capacity and its effect on recovery rates. Typically, we recommend having 4 kilowatts of heating capacity for every pound per minute of recovery you're looking to achieve. We buffer the capacity by about 25% to not strain the equipment at its working capacity. And for instance, if your target recovery rate is 3 pounds per minute, you should have a heater with 12 kilowatts of heating capacity. On the flip side, if the heating capacity is sorted out, it is important that there's enough cooling capacity. Butane, propane, and blends have different temperatures that they condense at, and it is vital to make sure that the cooling capacity is measured at the condensing temperature of the solvent, plus around 10 Celsius to account for thermal transfer inefficiencies. Butane, since it condenses at negative 0.5 Celsius, you would want to find a chiller that can go down to negative 10 Celsius and provide 12 kilowatts of cooling energy at that temperature. In a future video, we'll talk about the effect that pressure have on these numbers, but to keep things simple, I recommend using 4 kilowatts of heating or cooling energy for every pound per minute desired recovery speed. Next is the plumbing and process piping for both the heating and cooling side of the system. In order to achieve fast recovery speeds, the flow rate of your heat transfer fluid is vital for your process to remain consistent throughout the entire process from start to finish. This means that the plumbing from your heater and chiller needs to be as wide as possible to allow for the highest flow rates. And our recommendation is typically 1-inch diameter piping at the minimum, typically using copper piping. And for longer plumbing runs, we recommend going even wider to reduce any loss in flow rates. It's important to also account for the jacket port sizes on your equipment. For instance, connecting a 1-inch pipe to a 3/8 jacket port size is going to severely limit your heat transfer fluid flow rate and will require a component upgrade typically. Fixing these areas will greatly improve efficiency and speeds and are the most impactful ways you can improve processing throughput overall. If you're interested in the things I shared and want to see how we can help, mention this Tech Tip Tuesday and get a complimentary lab optimization from us. Thanks guys.